Welcome to The Explainer. Today, we're jumping right into one of the most exciting frontiers in AI agents. And no, these aren't just your everyday chatbots. We're talking about systems that can reason, plan, and actually take action out in the world.
Look, we're all used to AI that can answer our questions, right? But what if it could actually do things for you? What if it could take on complex, multi-step tasks all on its own? Well, that's the core promise of AI agents. And to really get a handle on how, let's meet someone with let's say, an impossible job. So, this is Alfred. His boss just tasked him with planning a massive gala. He's got to research a huge guest list, plan a fancy menu, find entertainment, and on top of all that, locate a missing, one-of-a-kind high-tech car. Yeah, a simple chatbot is not going to cut it here. Alfred needs an agent.
Okay, so Alfred needs more than a chatbot. He needs an agent. But what does that word really mean? Let's break down what separates a true AI agent from the pack and makes it the ultimate assistant.
So here's the key difference. Unlike a large language model that just gives you a response to your prompt, an agent is autonomous. It can look at its environment, it can make a plan, and then it can actually take action to hit a specific goal. You know, think of it like the difference between a research assistant who just finds articles for you and a full-on project manager who takes that research and actually gets the project done.
So how does an agent actually, think? It's not just a one-and-done action. It's actually a continuous loop that lets it reason and react to what's happening.
This right here is the agent's fundamental game loop. If you're a programmer, it's a lot like a while loop. It kicks off with a thought, where it analyzes the situation and plans its next step. Then it takes an action, like calling a specific tool. And finally, it makes an observation. It looks at the result of its action. And this cycle just keeps going. Thought, action, observation, over and over until the task is complete. And we can actually see what this thought process looks like. This is pretty much the agent's inner monologue. Before it does anything, it reasons through the problem, kind of like this. Okay, user wants the weather in New York. I've got a tool for that. My first move is to call the Weather API. It's this internal planning step that really makes an agent so much more than just a simple, reactive program.
And that brings us perfectly to the action part of the cycle. I mean, an agent's thoughts are pretty useless if it can't actually interact with the world. And for that, it's going to need some tools.
Right. So if the large language model is the agent's brain, then you can think of tools as its hands. A tool is basically just a function that the agent can call to do something in the world. Search the web, run a calculation, or ping a database. It's the bridge that takes an agent from just thinking to actually doing.
Now, how does an agent actually use a tool? Well, there are two main ways. The first is what we call a JSON agent. It's kind of like the agent writes up a work order, a structured JSON file that some other system has to pick up, read, and then execute. The second way, a code agent, is much more direct. It literally writes and runs a block of code, say in Python, to call the tool itself.
And this code-based approach, it has some serious advantages. Code is just naturally more expressive. It can handle complex logic like loops and if-then conditions that get really clumsy to describe in JSON. It's also modular, it's easier to debug, and, this is a big one, it can directly tap into thousands of existing software libraries and APIs.
And here's what that can look like. Let's go back to Alfred needing that gala menu. His agent might have a tool called Suggest Menu. So when Alfred asks for a formal menu, the agent doesn't just make up a suggestion. It actually generates and runs the code to call that specific tool and get the result. It's just a super direct, efficient, and powerful way to take action.
Okay, so we've got the basics down. Agents that can think, act, and observe using tools. Now let's level up and look at some of the superpowers you get when you start combining these ideas into more advanced patterns. First up is something called agentic RAG. Now, you might have heard of RAG, that's Retrieval Augmented Generation, where a model fetches info before it answers you. Well, agentic RAG totally supercharges this. It turns the whole retrieval process itself into an intelligent, multi-step task that's run by an agent. An agentic RAG system is like having a master researcher on staff. It doesn't just do one search. It runs a whole process. So for Alfred, it wouldn't just search for guest info. The agent would first rewrite his queries to get better results, then run multiple searches, using what it finds to inform the next search. It would then pull info from his private guest list and the public web, and finally, validate everything to make sure it's accurate.
But what about those really complex problems? Remember, the Batmobile is still missing. Finding it is a huge project. It's going to take web searches, complicated travel time calculations, and even data visualization. Honestly, that's way too much for a single agent to handle on its own.
So, the solution? You build a team of agents. In a multi-agent system, you have a manager agent who acts as the project lead. It breaks the big task down into smaller chunks and then delegates that work to specialists. So for the missing car, a web agent could handle all the online searching while the manager focuses on the big picture, piecing it all together and plotting the final map. It's basically a digital division of labor.
And this all brings us to the big picture. Why does any of this really matter? Well, because what we're talking about is a fundamental shift in how we're all going to interact with computers.
And just how hard are these real-world tasks? A benchmark called Gaia was made to find out. It tests these exact kinds of tricky, multi-step problems. And the results are, well, they're pretty eye-opening. Humans can solve these tasks with about 92% accuracy. Today's most advanced AI models, they top out around 15%. That massive gap is exactly what agentic systems are being built to close.
So when you boil it all down, this is a huge deal. We're moving out of an era of conversational AI, where we just ask questions and get answers, and into an era of agentic AI, an era where we state a goal and our systems can plan, act, and actually accomplish it for us.
The technology to build your own personal Alfred is moving incredibly fast. It's really not a question of if anymore, but when. So the real question to think about is this: when it finally gets here, what impossible, complex, party of the century level task are you going to give it first? Thanks for watching.